Okay, so last time we were talking about some of the basics of statistics, and we mentioned that we can take data from samples or populations, and we can also use several simple metrics to get an overall broad idea of what our data is doing. Now, let's talk a little bit more today about how we actually obtain that data and some of the things that we need to keep in mind when we are trying to get that data. So, first of all, two ways that we can get data are through observational studies and through experimental studies. Okay. So, first of all, an observational study is where we are just kind of observing what's going on naturally. We're not doing anything to try and get a result. We're not trying to change anything about the environment. We're not really putting ourselves in the picture when it comes to the study. All we're really doing is we're just observing and taking down data. So what you can think about as an example for this is if we wanted to know the average number of people that visit a particular store on a given day. So we might collect data over a few weeks by standing in front of the door to the store and noting the number of people that come in and getting that number. We're not doing anything to encourage people to come in. We're not doing anything to discourage them from coming in. We're just standing there and taking a number. And so that would be an observational study. We aren't making any changes that might influence the results. So what we can say about this is an observational study is where we observe to get our data and we don't control exposure. Oh, I put an extra E in there, didn't I? Okay. So what I mean by exposure isn't controlled is that we aren't changing anything. Whoops. Controlled. So we aren't changing anything. So we aren't, again, influencing people to come in or stay out. Now, if we did add something like that, maybe we sent out coupons for the store and we wanted to see how many people come in after sending in those coupons, that would now be an experimental study. We've changed something that is going to influence the results of our data. So an experimental study is where we are controlling the exposure. Oh my goodness. Okay. So again, going back to our example with the store, if we were to send out coupons, we could try to influence our data, and then we'd be looking at how many people come in based on those coupons. So we'd be observing that. Or we could send out information about the prices of certain products in the store. Again, that would be influencing who's coming in and the rates that people would be coming in each day. So now we are influencing how this study is going. So we're not just observing anymore, now we are experimenting. And so that's why we call this an experimental study. So there's some things that we need to keep in mind when we are dealing with an experimental study or even an observational. And that is we are going to need two groups. Okay. So we have a treatment group and we have a control group. So what the treatment group is it's a group that is going to get a change of some sort. It's going to be some kind of exposure that we control. So for instance, if we were observing plant growth and we wanted to test and see what sort of factors contribute to how a plant grows, we might start changing some things. So we might give a plant more water or less water. We might change the soil. We might change the type of light that it gets. We might change the amount of light it gets. We might change the temperature that the plant's at, its humidity, all sorts of things that we could change. And so this group is what would be receiving those changes. So it gets exposure to change. The control group, on the other hand, is a group that we need to have in addition to the treatment group, but it will not get any of those changes. Now, it's important to have both of these groups. One, the treatment group, obviously, we need so that we can observe what's going on with these changes that we're making. But also, we need a control group so that we can compare those changes to the baseline. So the control group is going to be, again, going back to our plant example, if we change something with the treatment group, that control group is not going to get it. It's just going to be a normal plant. Nothing else is going to be different about it. We aren't going to give it different soil. We aren't going to give it a different amount of water. We aren't going to give it a different amount of light or different types of light. Any of those things that are listed, it's going to be a normal amount. The treatment group is going to be the thing that gets the changes. And so, again, using these groups in tandem, we can use the control group to compare to the treatment group and see what sort of changes we observe. And then, if we do see some differences between the groups, it could be the changes that we made to the treatment group that caused those changes. Also, you know that if something happens to the control group that's unexpected, then you can figure that out of what happened to the treatment group. So the example I gave in class today, if we were testing fertilizer on these plants, the treatment group would get the fertilizer and the control group wouldn't. They get everything else the same, but the treatment group would get the fertilizer. Now, if both groups of plants die, both the treatment group and the control group die, then you know that the fertilizer probably wasn't what killed the plants, because the control group, which didn't get the fertilizer, also died. So it's something with your test setup. We need to go back and review how we set up this experiment and see what we need to do better to keep these plants alive in the next test. Okay, so control group is very important to have along with your treatment group. Okay, next. The way that we carry out studies with these two groups can also be different. So one way that we might control our study with these groups is with a single blind study. So in a single blind study, the members of each group don't know which group they're in. They don't know if they're a treatment, they don't know if they're control, and as well, they don't know what selections they might be making. So for instance, if we wanted to have people compare the taste of two different sodas, the test taker, the researcher conducting the test, might actually, know what's in the two cups, but the person tasting doesn't. So they're blind. That's why we call it a single blind study. So in a single blind study, the important part is that the researcher knows who is in what group. And again, it doesn't have to be a who. It could be, like we're talking about with plants, it could be a thing. But only the researcher knows what is going into what group. And of course, the plants don't know what group they're in. They're plants. They don't have brains. Okay, so then we also have the double-blind study. In this type of study, not only does the participant not know who's in what group, but the researcher doesn't know either. Okay, so another example that I gave in class for a double-blind study is Mr. James Randi. And James Randi is a very fascinating figure, I think. He is a skeptic, and he is a person that knows a lot of tricks that people tend to play when they're trying to scam someone. He's a magician. He knows a lot of illusions. And he's very good at figuring out how people are pulling off tricks that make them seem like they have supernatural abilities. He's debunked lots and lots of people who claim to have supernatural abilities, and he has a foundation which offers a reward to anybody who can prove that they have supernatural abilities. Now, in proving these, or disproving them rather, there are some times that we need a double-blind study. And so I'll give you an example of one of them. There was a woman who was claiming that she could make psychic readings off of pictures. Okay? And so I believe it was that she could tell who had been murdered, and she could pick that out from a group of pictures. And so what the foundation did, what James Randi's foundation did, is they got a group of pictures. Some of the people in these pictures had been murdered. Some of the people in these pictures were just fine, everyday people. Again, we have a control and we have a treatment. And so the person claiming to have psychic abilities would go in. These pictures would be in folders so that you can't see them. And they would have to open the folder, look at the picture, close it, and make their decision. Now, the researcher in the room with them can't really know which pictures are the correct pictures and which ones are the false pictures. Because if the person claiming to have psychic abilities were to pick that up and look at the picture, they could also look at the researcher and use visual clues from that researcher's body language and make kind of a cold reading and try to guess if this is the picture that they need to label as a person having been murdered. And so in a double-blind study, if the researcher doesn't know, so someone else comes in and randomizes those pictures, the researcher doesn't know which pictures are which, the person who randomized them is not in the room, the person who randomizes them afterward, after the researcher takes down the notes and takes down the data, that other person who randomized them can take all the data and decode it. And so they can see if we had positives or negatives. And of course, no one's been able to pass that test. In fact, James Randi has not found anyone with any kind of supernatural powers. No one's been able to claim that money, even though a lot of people have tried. Okay, so a single blind study is perfectly fine. There's no reason that you should think that a single blind study is better than a double blind or vice versa. It really just depends on the requirements of the test, whatever study you're trying to do, as to how you're going to eliminate bias or deal with your study. Okay, so next, let's talk about some of the more specific things that we need to worry about when we are doing particular studies, whether it be an observational, experiment, a single blind, a double blind, whatever. We always have to keep in mind variables. So variables are things that can change. They are factors that can change. Okay? So for instance, going back to the plants, we can change the amount of water they get. We can change the type of soil they get. We can change the amount of sunlight they get. We can change the temperature. We can change the humidity. All of these would be labeled as variables. And in a study, you really want to eliminate as many of these variables as possible. You want everything to be mostly the same, and you want to change just one, maybe two things about the treatment group. Okay? So there are several types of variables. Variables themselves can be broken into two different types of variables. One is dependent variables. Dependent variables are variables that change based on another variable. So, for instance, if we have people's heights, okay, how tall a person is, their height is likely dependent upon their genetics. So, certain genes will code for certain heights. So, their height would be dependent or a dependent variable of their genes. So again, a dependent variable is a factor that changes based on another variable. Okay? Now, opposed to this is the independent variable. Okay, so just like it sounds like, this is a variable that isn't dependent on another variable. It isn't changing because another variable changed. So, for instance, your age. Your age isn't affected by other outside variables. Your age isn't affected by your genes. Your age isn't affected by your weight. Your age isn't affected by your height. It's independent. The only thing that does affect it is the fact that time moves. Okay? So again, we have dependent variables that change based on the change of another variable, and then independent variables that don't change because another variable changed. They are their own. Okay, so a bit more specifically, there are variables that we need to consider for tests. Dependent and independent are very general types of variables, but we need to focus on some specific ones for when we're doing our tests and our studies. First of all, control variables. Control variables are the ones that we want to have just flatline the same between all groups. So again, going to the plants, that would be, we don't want to change the soil, we don't want to change the amount of water we get, we don't want to change the amount of sun, we don't want to change the temperature. All we want to change is that one gets a fertilizer, and then the control does not get that fertilizer. So everything else is the same. So all those things that are the same between them are the control variables. Okay. Then we have experimental factors, experimental variables. Okay, so these are the things that we will change, but only change for the treatment group. The treatment group is the only one we want to have any changes with. So, again, with the plants, if we give the fertilizer to one set of plants but not the other set, that is an experimental variable. Okay. We also have explanatory variables. So these are the variables that could explain why something is happening. Okay? So imagine that we want to learn about obesity in America. And so particularly we want to focus on the weight gain. So what is causing so much weight gain among so many people in America? Well, there are lots and lots of different things that we could focus on, but we could also, narrow it down to, for the sake of this example, fast food. So, fast food generally isn't the most healthy option for you to eat. So, we could look at that and say this could be an explanation for why there's so much obesity in America. It's an explanatory variable. However, the thing to remember about the fast food is that there's lots of different types of fast food. Is it just one type that's causing obesity, or is it all the types? Even if you just look at one meal, most fast food is served with a soda, and those sodas are very sugary, and sugar is something that is very fattening. So all of these are explanatory variables. They're variables that could explain why a particular event is happening, but we don't know if they are independent variables. Okay, so it could be that the soda is causing it. It could be that McDonald's type food is causing it. It could be that Chipotle is causing it. It could be all of these different things. It could be all of them. It could be one of them. It could be a mix of them. So explanatory variables, again, are variables, factors, that could explain a phenomena. Oops. But we can't tell if it's an independent variable. Oops. Okay. Next, we have a confounding variable. So a confounding variable is what I was talking about on Friday when I was mentioning the example of the firefighters and the damage that fire causes. So to reiterate it, I said that the more firefighters arrive to a fire, the worse damage the fire causes. And we said that that doesn't obviously make sense. There's something else going on there, and that is, it's the fire. The fire, the bigger it is, the more damage it causes. And so, also, the bigger the fire is, the more firefighters you'll need. So, even though those two change, remember, dependent variables change based on another variable, just because the more firefighters arrive, the more damage is caused, doesn't mean they're actually dependent upon each other. Really, the more damage is caused by the fire being bigger. So that is what we would call a confounding variable. So a confounding variable is an extra variable not accounted for that can suggest incorrect correlation. And what I mean by incorrect correlation is not related. Okay, so again, firefighters, the more firefighters are showing up doesn't have to do with damage. It's not related. It's not correlated. Ice cream sales, again, ice cream sales are not actually related to murdering. Ice cream does not cause murder. These are all confounding variables. Last, we have the placebo. So remember that in any study that we do, we don't want the treatment group and the control group to know that they're in a particular group. So we don't want that person that's in the treatment group to know they're in the treatment group. One reason is because of the placebo effect. So if you have a person and you give them a pill and you say that it does a particular thing, they're going to tend towards believing that, and they will start to see observations about their own body that might not actually be true. They're just making the connection that, well, I got this pill that's supposed to do this, and I noticed that this happened, so the pill must work. Okay, that's the placebo effect. So we want to cancel that out. We don't want either group to know whether they have the treatment or not. So if you're researching for a drug, you want to introduce a new drug for a pharmacy. The pharmacy will, or the pharmaceutical company, I should say, will do a study where they have a treatment group and they have a placebo for the control group. Again, the treatment group gets the actual drug, the placebo goes to the control group, and neither one knows which one is which. So they can't have that phenomena where they think they're having the benefits of the drug happen to them, because they don't know if they have the drug or not. So a placebo is a factor that conceals. That's not how you spell conceal. How about confounds the control group? So it masks the control group. No one knows who the control group is, at least not between the control group and the treatment group. So again, we need that placebo sometimes so that we can make sure that people don't start making observations that aren't actually there. Okay, so that will cover it for today. Next time in class, we're probably going to have a just general work day. So what I want you guys in the Zoom class to do for Wednesday, and I'll email this out again just in case anybody misses this part, is I want you to work on Hawks and make sure that you have everything done for Miss Lamar. And then, of course, if you really want to, which you should, keep on working on those Hawks lessons. And I don't mind if you get ahead, and I'm sure Miss Lamar doesn't either. So other than that, I will see you on maybe Wednesday, but probably Friday. And I hope everyone has a good day.